All right, we're still looking at box and whisker plots. This is the second video for this lesson, and we're on example 3. So this says comparing box and whisker plots. The double box and whisker plot represents the test scores for your class and your friend's class. So here's the box and whisker plot for each. So it says identify the shape of each distribution and which class test scores are more spread out, and explain why. All right, so if you remember, we looked at this earlier in the previous video. If it's symmetric, that means it looks like it's pretty much the same on both sides. So if you can draw a line through the median of the box and whisker plot, and each side is approximately a mirror image of the other side, then the distribution is symmetric. Okay, so that looks like this right here. Okay, if the whisker on the left side is much longer, then it is skewed to the left. If the whisker on the right side is much longer, then it is skewed to the right. All right, so if we look at this, you can look at your class. The whisker on the left side is much longer, so I would say that your class is skewed to the left. On the other hand, your friend's class looks like it's approximately symmetric. All right, so it says identify the shape of each. So I'm going to put this one is skewed left, and then your friend's class, we're going to say it is symmetric. And it may not be perfect, but if you draw a line down through the median and you flip this over, like if you had it on a piece of paper and you folded it in half, one side would be almost the mirror image of the other side. So this one does look symmetric, where this one does look skewed. All right, so it says which class test scores are more spread out. So what tells you if something is spread out? So we can either think about the range or the inner quartile. So if we look at the range first, we can say that the range is your highest number to your lowest number. And you can see that both classes are 100, but they have a different lower score. So for your class, it's 100 to 70. So there's a range of 30. And for your friend's class, it's a range of 40. So that means the range would tell you that your friend's class is more spread out. So let's check the interquartile range as well. So the interquartile range, remember, that's Q3 minus Q1. So let's look at both classes again. So we'll start with your class. That's on top. So we're going to look at it first. The interquartile range is 95 minus 85. So the interquartile range for your class is 10. And the interquartile range for the second class, or your friend's class, would be Q3 minus Q1 would be 90 minus 70. 90 minus 70 is 20. So you can see that your friend's class, the number here is bigger, and both the range and the interquartile range for your friend's class is bigger. So it should be obvious that your friend's class is more spread out. And that's how you would explain that. All right, so be able to look at the shape of the box and whisker plot and tell what shape it is. Is it skewed left, symmetric, or skewed right? And then also be able to tell which one's more spread out. So just looking at basic information based on the box and whisker plot that is provided. Example 4, modeling real life. A manager makes a list that shows the batting averages for players on a baseball team. Make a box and whisker plot that represents the data. Describe the shape of the distribution, and does the data set contain any outliers? All right, so I'm going to pause the video. I want you to take just a few minutes. I want you to list these in order from least to greatest, because in order to make a box and whisker plot, we first have to have these in order so that we can find the median, and then find the median of the lower half and the median of the upper half. That's how we find that interquartile range. All right, so go ahead and do that. Go ahead and find all 5 numbers for the 5-number summary. Remember, the lowest number, the highest number, and then Q1, Q2, and Q3. Once you do that, you can unpause the video and we will work together. We will work through this together, but it's good if you take a little bit of time and try to do this on your own to see if you really understand what you're doing. All right, so I took these numbers from the table and I put them in order from least to greatest. You can see it goes from 0.174 all the way up to 0.406. So I noticed that I have 12 numbers, and the first thing I need to do is find these 5 important numbers that we call the 5-number summary. Okay, and that's how we make a box and whisker plot. So the first thing we need to do is find the median. Well, that's what I do first every time. So the median is going to be, you take the 6th and 7th number and divide it. When this is an even number, 12, there's 12 numbers here in the data set. We take the middle 2 and average it. So 0.28 and 0.29, halfway between that would be 0.285. So 0.285 is the median. All right, so it's obvious the least value is 0.174. The greatest value is 0.406. Now we need to find the median of the first half. So this is the middle. What's the median of these first 6? So 1, 2, 3, 4, 5, 6. That means these middle 2 here have to be averaged. So that means our first quartile, our Q1, is going to be 0.262. That's halfway between 0.26 and 0.264. So 0.262. All right, and that means the last thing we have to find is Q3. So I have 1, 2, 3, 4, 5, 6 numbers again. So it means I got to take the middle of these 2 numbers here. So take the average if you need to. Type this in your calculator, 0.311 plus 0.325. Divide that by 2. That's going to give you approximately 0.318. And 0.318 again falls halfway between these 2 numbers. All right, now that we have these 5 numbers, okay, we're going to draw a number line again. So if we draw a number line, we don't have to have these exact points on here because these numbers are all kind of random. They're not evenly spread out. So we do need to have even numbers on a number line. So let's start with a number less than our lowest value. So we're going to put 0.15. All right, and then let's do 2. And then that's 0.2. 0.25. And then 0.3. 0.35, and then 0.4, and then 0.45, and 0.5. Now, do we have numbers that go from below here to greater than here? The greatest number is 0.40. So yes, that's as far as we need to go on the number line. Now, why did I do that? Because these numbers are evenly spread out, even though these are not. When we draw the box and whisker plot, we need to be on an even scale. So now we can take the numbers that we found here and put those where they belong. So 0.285. 0.285 is going to fall between 0.25 and 0.3. So I always start with my Q3. I always start with the middle of my box. So there's Q3. All right, now I'm going to do Q1 and Q2. So 0.262, 0.262. So this is 0.15, this is 0.2, 0.25. So it's still going to be just above that. So it's not going to be too far from here. That's going to be Q1. All right, and Q3 is 0.318, 0.35, 0.30. So that would be right in here. And that is actually my Q3. I don't know why I put Q3 in the middle. I always start with Q2. And I know that, but for some reason I wrote Q3. Let me rewrite that so that that's easier to read. All right, so this is Q1, Q2, and Q3. So I started with Q2. I started in the middle with my median, and then I found Q1 and Q3. All right, now I need to use the least and greatest value to find my whiskers. So this one's 0.40. It's going to be just above this mark here. And then my least value is 0.174, so 0.15, 0.16, 0.17 would be just on the inside of here. All right, so hopefully you can see what I've done. And this would be your least value. This is your greatest value. And then you've got your Q1, your Q2, and your Q3. So these are your five numbers. That gives you your 5-number summary. All right, now let's go back and look at the questions. It says make a box and whisker plot that represents the data. Okay, we did that. Describe the shape of the distribution. Okay, what does the shape look like? The whisker lengths are about equal, so, and the median is about in the middle. So I would say this one looks about symmetric, okay? This one looks just about symmetric. So we're going to say this one is, let's see, let me put this up here. All right, so this one was going to be, all right, and B part says, does the data set contain any outliers? All right, so if we look at Q1, or their interquartile range, and we do Q1 minus the 1.5 times the IQR. So there's a formula that you need to know. So the first thing we need to do is find the interquartile range. So we can do Q3 minus Q1 to find the interquartile range. So the interquartile range is 0.318. That's right here. And minus 0.262 right here. We found that earlier. So that means the interquartile range would be 0.056. All right, so that's our interquartile range. Now, there's a formula that you need to know to find any outliers. So that formula would be Q1 minus 1.5 times your interquartile range. And then to find the other one, it would be Q3 minus 1.5 times the interquartile range. All right, and I am running out of space very quickly, but your interquartile range is this number right here. So I'm going to do 1.5 times that number and then take the 0.262 and subtract 1.5 times my IQR. All right, if I do that, I get 0.178. 0.178 is larger than this number here. So that means that this 0.174 is an outlier. All right, if I do the Q3 minus 1.5 times my interquartile range, again, Q3 is given. My interquartile range, we found it right here. So 0.318 minus 1.5 times 0.056 equals 0.402. 0.406 is larger, so we do have two outliers. And my two outliers would be that right there. And that has answered both questions. If you have any questions,